To South Africa now, where engineers have developed a 3D printed ventilator that can assist multiple COVID-19 patients at once. The ventilator is portable and allows for off-grid operations for up to 1.5 hours. CGTN's Lisa Njamela tells us more.
South Africans continue to innovate new products to curb the spread of the coronavirus, and the University of Johannesburg is at the forefront in terms of those innovations to fight this coronavirus. In April, the Institution of Higher Learning created open-source cheap ventilators to help fight the COVID-19 pandemic. During the same month, UJ developed 3D printed surgical face shields in an effort to meet the rapidly growing need for personal protective equipment for healthcare workers. And now, the university has developed 3D ventilators. The ventilators have a customizable base plate to treat multiple patients. Named Ora Imprimere, meaning a breeze of air provided by printing. The ventilators have a battery system that will ensure normal functioning, whilst the demand for electricity currently exceeds the available supply here in South Africa.
Well, what we did is that the base plate was 3D printed using a material called PLA. And the 3D printer concept is basically coming from the Lego design concept. And from, with the Lego design, what you can have is that you can have multiple components that will be able to put in a second additional ambu bag. South Africa has a problem of power outages and what is called blackouts. So one of our undergrad students, Mr. Malcolm Lowe, suggested that we use lithium-ion batteries as part of this design. So what we did there is to superimpose lithium-ion batteries into the design so that it can last for 1.5 hours without the need of an electrical grid connection.
An ambu bag is a handheld device commonly used to provide positive pressure ventilation to patients who are not breathing or not breathing adequately.
The ambu bag is centered with these locks, and these locks make sure that the ambu bag does not move and always keep its center. They can be adjusted to any bag size.
The team also ensured that there is a solar mobile lab to enable continual use of the devices.
The ventilator we designed uses DC power source, but we have a converter unit that can convert from AC to DC. But the interesting thing about our project is just beside the ventilator, we also have a solar mobile lab that can ensure that once the battery runs out, the solar-powered system can continuously provide electricity to the ventilator. So you can have a 24 hours a day energy from the solar system based on the trailer that is attached to it. Yeah.
The UJ engineering team has also made the blueprint available to the public in order to develop the design further. Lisa Njamela for CGTN in Johannesburg, South Africa.